This is lesson 9 for year 13 physics under DC electricity and capacitors, and this lesson is about charge and energy storage in a capacitor. So when a capacitor is charged, it stores electrical potential energy in the electric field that exists between the plates of the capacitor. Now, if we draw a graph of voltage against charge for the cell, this is a straight line showing you that every coulomb of charge that enters the cell gets the same amount of energy. And so if you look at the definition for voltage, voltage is the electrical potential energy per charge. Rearranging the equation, you get electrical potential energy is V times Q. So it's V times Q. So your V times Q is actually the area under the graph. So the area under the graph tells you how much energy is stored in the cell, how much about the energy of the cell. Okay, but however, if we do a graph for the capacitor of voltage against charge, before the capacitor is charged, the voltage across its plate is 0, and as charge accumulates on the capacitor plates, the voltage goes up. So you get a line that looks like this, and again it's the area under the graph that tells you the amount of energy that's stored in a capacitor, and this is the area of a triangle, which is half base times height, so you get half Q times V. So if you compare both these formulae, only half the energy that's supplied by the cell is stored in the capacitor. So what happens to the other half? It's lost in the form of heat due to resistance of the wires, because charges have to move through the wires in order to reach the capacitor plates. Now there's also alternate forms of the same formula for the energy stored in a capacitor, and it's all based on this formula, C is equal to Q over V. So this is what we got on the previous page. So if you substitute Q as C times V, you get EP is half CV squared, or if you substitute for voltage, which is Q over C, so you get EP is half Q squared over 2C, or sorry, Q squared over 2C, or half Q squared over T. C. Now if you come to the time constant, the time constant is the time it takes a capacitor to get charged, and it depends on two things. It depends on the capacitance, because bigger the capacitance, the longer it will take to get charged. So time constant is directly proportional to capacitance, and the other one is resistance. So the greater the resistance, the smaller the current, and hence longer the time it takes to get charged. So the time constant is also proportional to resistance. Now when you put both those two together, you get time constant equals RC, and this is what all the letters stand for in the formula that we've used.